Hi, I'm Dan from Kagool. I want to give you an overview of some really cool technology that's just been released from our innovation team. It's called Velocity MR, and MR stands for Mixed Reality. Now, what it does, it's providing an additional level of visualization and interaction capability on analytic data, and it's powered by the Azure platform. And as many of you may know, since we are predominantly an SAP consultancy, we've got lots of examples where we ingest the SAP data and augment it into these mixed reality experiences. So got an example model to show you. So if we just zoom out a little bit, so anybody that's familiar with Kagool at some of the events that we do in the UK may be familiar with this this contraption. So what this is it's a simulation of a production manufacturing scenario, and what it does, it's an electronic Lego kit which mines different coloured Smarties, M&Ms, etc. So they go up this conveyor belt, so up the scoops, up the conveyor belt, and then we've attached a series of IoT sensors to the Lego, and further up here, what they do is it captures the telemetry of the different objects that's going up the belt. So it works out the colour, the weight, the dimensions, etc. And what that does, that information gets fed into streamed, I should say, into Azure Analytics Suite, and from that point the information is then used to calculate what is it. Is it a blue M&M? Is it a brown Malteser? So on and so forth. It's just really a bit of a simple use case of connecting the real life IoT sensor data and then transporting it into a digital form, and then we represent the information on a Power BI report. Okay, and then I can just switch it on just to give you an example of what happens. There you go. So I think that's the physical representation of what we have, and that's what we've been demonstrating quite a few times at events in the UK. Now, taking this further, I just want to show you what the MR solution, how it works. So essentially we ingest the SAP data and IoT data into Azure using our Velocity product. That's the existing ingestion toolkit. And then, as you can see, as I said before, we present the information using Power BI, and now we're presenting the information through Velocity Mixed Reality tool. So I'll show you an example of how that works. So if I just bring my marker. So you can have any number of marker. This is called a marker. So this is basically what triggers the model. So if I just log on. Okay, so trigger. Here we go. Right, so what have we got here? So apologies, I'll reposition the camera. There we go. So what's happening now is, there we go. Apologies, the light's in the way. Let's do that one more time. That's better. Okay, so what have we got? We've got this is now a digital version of the physical Lego model that we have in the background there. Okay, and it's triggered based on a QR code, which is what's displayed on the iPad. Now, it doesn't have to be a QR code; it can be anything. You can actually trigger the image off the actual machine itself, and you do that through taking lots of photographs and running that through some cognitive recognition tools, which is easily doable, but we didn't decide to do that for this model. So as you can see, here's the model. It's displayed on this tablet. I can interact with the model, so I'm just moving it left and right. It does some cool things, so it's spinning, etc. What else can you do? So we can actually, because this is this model's been built from scratch. You can create these models by importing a CAD image or CAD files, but we as there's no CAD files available for this Lego excavator, we had to build this from scratch. So this took about 2 weeks to build, with quite a sizable team doing it. So there's about 4,000 individual parts that needed to be created. So if we zoom in, so we zoom in by just basically moving closer into the model, and there's something interesting. We go, so we can actually zoom right into the internal workings of the actual model, so you can actually pass all the way through it if you wanted to. And what else can we do? We can, you'll probably see these little bouncing, I should say, bouncing diamonds. So what do? So they're interaction points. So that's telling me I can click on it. So if I click on it, it's now giving me some information. So I've now pulled up the equivalent of what would be a Power BI report in the old method of displaying this. So this is giving me information on exactly what was on the Power BI dashboards, but actually I can interact with it on this model. So it's telling me how many M&Ms have we mined so far, so that's 108. How many green ones, orange ones, yellow ones, so on and so forth. And then I've got some various other bits of telemetry of what's going on the devices as well. So the machine's obviously switched off, so this is the last information that we captured before we switched it off. Okay, so I think what I'll do now is I'll just toggle between this camera and the actual display from the tablet itself, which will give you a much better viewpoint of the model. So just bear with me. Okay, so you're now looking at the full screen of what is being displayed on the tablet. So you obviously can't see my fingers as I'm adjusting the image, but it's the same principle. But you'll be able to get a much better understanding of the visualization of the quality of the graphics. So okay, so what can we do? So if we have a look at the model from left to right, so okay, so we've got some little secret bit of telemetry there. So that's just giving us some information on we've got geolocation, so we've got GPS sensor on the machine as well. So it's here in Coventry. We've got some machine health stats, so that's calculated, and power levels, so that's coming from the batteries. Okay, what else have we got up here? Okay, so this is quite interesting. So here we've got some SAP data. So if you recall what I showed up here, actually I might just go over to it. So we ingest any and all data from SAP. Oopsie daisy, don't know what's going on there. Any and all data from SAP. Actually, I'll come back. It seems to be having a fun time. So we ingest all the data from SAP that we want to consume as part of the visualization on the model. And some of that information is plant maintenance. So as you know, there's lots of different use cases for planned and predictive maintenance improvements that can be performed when you ingest all the IoT data, and that's basically what we're visualizing here. So we've pulled in some planned maintenance activities for this piece of equipment. So we can see that there's the conveyor track 3A. These will be resealed on the 19th of December, 2 years time. Then we've identified some predictive maintenance tasks, so cutter head replacement, and this is all test data. And we can pull all the recent maintenance activities as well. So this can be as complicated or as simple, this visualization, as you'd like. What we're trying to display, indicate is the capability of sucking any data from SAP into Azure, and then rendering it against a model, a visualization like this, which is specific to a piece of equipment that the user's looking at. So in this instance, we're using an iPad to look at it. In the future, well, I say the future, later on this year, you'll be using HoloLens 2 when that becomes available. So this model is developed. It's HoloLens 2 ready. It's developed using the same technology that HoloLens 2 requires. So what that will mean is that you won't have to use an iPad. You'll be able to interact with your fingers, like that. I don't know if you've seen the gesture controls that you have available, so you'll be able to use finger gesture movements to then interact with this model instead of having to use the two-dimensional interaction points, which is the touchscreen. So some of the cool things, again, as this is a 3D, it's a digital twin of that thing there. Yeah. So what does that mean? So it means that you can. That's the physical representation. Imagine a solution like that will probably have, I don't know, probably 10,000 IoT sensors on it, spread across the entire piece of equipment. So those 10,000 sensors can be visualized on here. So, and those sensor readings, you might not want to have them all displayed at once. So you'd have these things here, these blue blue symbols. You could make them red, amber, green. So red would indicate that you can come into here, explode this part of the model out to look inside it, and then as you go in and navigate inside, you'll be able to see the offending piece of equipment, which will have some telemetry against it, which will indicate why it's not performing as per specification, or it's running outside of tolerance, I should say. And the user can zoom into this. So it's like, if you imagine a real life scenario, you could have imagine a train that's set off from London to Edinburgh, and it's continuously streaming out IoT telemetry back to base, which will be Microsoft Azure platform, which will be monitoring the train's performance. And then Azure, so the tools that we provide within Velocity can identify a piece of equipment that's running outside of tolerance, and then we can alert an engineer, and then the engineer could actually come straight into a model, a digital twin model such as this, and then be able to zoom in, look at all the different bits of all of the telemetry readings, which will be coming out of or being recorded by this piece of equipment, and then potentially be able to diagnose what's wrong or what needs to be fixed. And then, so by the time that train reaches Edinburgh, no one's actually had to physically open up physically inspect the engine or the train. They could have been able to potentially diagnose the problem and order a replacement part and get it fixed when it reaches Edinburgh. So what it means is it's actually quite incredible amount of capability that it's providing businesses to reduce the amount of downtime that they have with equipment failures, because you've got access to nearly all the, apart from clearly you don't have the physical equipment in front of you to look at, but if you can provide all of the telemetry readings for the thousands of pieces of individual components, provide the ability for somebody to zoom in like this to inspect things, click on all different kind of bits of widgets and things, click on it and see the metrics or telemetry of that component, and then you've got a pretty good chance that they'll be able to diagnose problems without, quicker, faster. And I think when we've got large, expensive pieces of kit, the amount of downtime can be a considerable cost to the organisation. So other elements of the use cases, I should say, are in training. So when you've got users or engineers that need to train on understanding how bits of equipment work, need to take them to bits, etc. Deconstruct them for servicing. These models can be very useful to help, especially when the realities, they are very big things like that. You don't want 20 of those in a training studio or training environment. You want to try and provide as many kind of digitalized solutions as possible. And I think that's where, I mean certainly when HoloLens 2 comes out, that'll be a great benefit. So I think that's probably all I wanted to show you. So I mean the technology's here. It's great technology, and as an end user, we can actually. So one thing I didn't say is that we can actually input data back into Azure from here as well. So if we wanted to capture data as part of my inspection of this machine, I could do that from here. So that could I'd put my ID would be captured, capture all the information, type into a form, and then press save, and that information will go back into Azure. And if you wanted to, that could go back into SAP. It all depends on the business use case. So I think that's all I wanted to say. So if you're interested in any of this technology, feel free to get in touch. Info@kagool.com is the contact point, and thanks for your time. Thank you.